Hello! This video is about how to solve parallel circuits. Let's start by making a comparison between series circuits and parallel circuits. A series circuit has only one path for the current to flow. So the current will come from the battery, go through all the resistors, and then go back to the battery. A parallel circuit, in contrast, has more than one path. This circuit has three paths. There's current can follow this red path, or the blue path, or the green path. So a parallel circuit has more than one path for current to flow, and because of these multiple paths, the circuit will behave differently, particularly around voltage and current and resistance. Let's look at how this works. Voltage in a series circuit is the same across every branch, so each resistor gets the full battery voltage. That happens because if the current only goes to one resistor, then that resistor can get all of the volts. For example, the green current, in the diagram on the top, only passes by one resistor, so there's no sharing of voltage required. Current in a parallel circuit is split between the different branches. The total current provided by the battery is the sum of each branch current. For example, the battery has to provide current for the red branch, and current for the blue branch, and current for the green branch. So the battery current is the sum of the individual currents across each branch of the parallel circuit. Because of those two things, resistance in a parallel circuit, because of all these multiple paths, the resistance will be lower with more resistors, not higher. In fact, the total resistance of a parallel circuit will be less than the smallest individual resistor. We'll see why that is in a little bit. So how do we calculate the resistance of a parallel circuit? There are three ways to do it. Here's way number one. This equation will only give you the equivalent resistance of two resistors in parallel at a time. Here's a second equation. This one will work for any parallel circuit, but it gets a little bit complicated. And there's a third strategy which I recommend starting with, and we'll see that when we do a problem in a moment. When we solve circuit problems, any kind of circuit, you want to start with the thing that is the same everywhere in the circuit. In a series circuit, that's the current. The current is the same everywhere in a series circuit. So you're going to start with the whole circuit, start by finding the current in the entire circuit, and then you're going to solve the individual resistors. A parallel circuit, you want to take the opposite approach. Because the voltage is the thing that's the same across each branch of the circuit, you're going to start with the individual resistors and then move to the whole circuit. Let's see what that looks like with a sample problem. Here is a parallel circuit. We have a 12-volt battery and two resistors, a 2 ohm resistor and a 3 ohm resistor wired in parallel. We have blue current. We can show the blue current running through the 2 ohm light bulb and a different path for current running through the 3 ohm light bulb. Here's how we solve this problem. The first thing to do is to remember that the voltage is the thing that is the same across each branch of the circuit. That means the blue circuit carries 12 volts and gives all 12 to that light bulb, and the red circuit carries 12 volts and gives all 12 volts to that light bulb. So the voltage is going to be the same as the battery voltage across each branch of the circuit. Step 2, we can use Ohm's law, V equals I times R, to solve for the individual currents. I equals V divided by R, so 12 divided by 2 is 6 amps of current for resistor 1, and 12 divided by 3 is 4 amps of current for resistor 2. So the blue current is 6 amps, and the red current is 4 amps. Step 3, we're going to find the total current provided by the battery. We just add them up. 6 amps blue circuit plus 4 amps red circuit makes 10 amps that the battery has to provide. Last step, we can use Ohm's law again to solve for the effective resistance of the entire circuit. how much resistance does the battery feel? That's voltage divided by current. So we get 1.2 ohms of resistance for the entire circuit. Notice that the voltages are the same, the currents add up, and the resistance of the whole circuit is less than the smallest individual resistor. You could have also calculated the effective resistance by using one of the other two equations on the previous slide. That's how you solve a problem with parallel circuits. Thanks for watching.